All right, guys. So here's the story. I'm going to pass back your exams, but the only thing I've really marked off anything are your multiple choice problems. And you, Omar, since I just got your other ones, I haven't really marked those. Okay, but I marked which ones you got wrong, and then what we're gonna do is we're gonna like pretty much the the tail end of like this year, like what I consider the tail end, like month 8 and 9, are just going to be focused on doing some problems, like for homework, and doing your test corrections. That's pretty much it. Like, I mean, I found in like the archives that there is technically an exam for month 8, but I don't think I want to do it. Really, only because I think it just adds to the confusion and it takes away focus from actually just looking back at what we did so far. I feel like sometimes we've kind of just rushed to the finish line to get these tests done without really going back and really assessing if we really got to reanalyze and like fix up or like look at the problems that we didn't understand and really fix them up. Okay. So it's like quality control, going back on like things that I'm like, did you actually get month 6 and 7's exam? I think month 6 was extremely tough too. So if you can start bringing in or I think I have like test corrections or whatever, just get access back to your exams or start bringing them in. Okay. And we're going to start looking at them because I would say the next 3 weeks of this month and even the next 4 weeks of next month, we're just going to be looking at old exams. We're going to be looking at new FRQs. I heard last year about something about like an infamous banana problem that no one knew how to focus on, or no one knew how to, solve. So the good thing is all that information I think is released now. So I can kind of dig back and then I can kind of bring it up. Okay. So today we're going to look at some multiple choice problems that you may have missed on month 6 and month 7, like maybe 3 or 4. And then we're going to go over the FRQs for month 7's exam. Okay. So I do need these tests back though, only because I haven't actually graded your FRQs, which is kind of nice because when you guys are working together, you don't know if you actually got the right FRQ or not. Okay. So when I call your name, just go ahead and grab it back. Omar, it's in alphabetical order. So just Aaron Chiswick, Kyle, Josh, Nathan. Here you go, Mr. Morgan, Josh, Nathaniel, Deja, Anthony, Allie, not here at the moment, and then Benjamin. Okay, so I don't know how eventful this class will be for you. Okay. All right. Here's your warm-up problem. I'm going to pull it up right now. So we're going to start with something that's still familiar. Not going to be like, I'd say the next few questions that we're going to go over are pretty tough. But this question, I hopefully would suspect that you can solve this. So go ahead and work with a partner on this. So this is going to be all partner work, a lot of communication on how to solve these test problems. Okay. But let's go ahead and work on this one here. Find the limit as x approaches infinity if you have x to the third power over e to the power of 3x. Okay. Sorry. So go ahead and work on this. Yeah. Go ahead and work on this guy. This bad person. This was the one. Okay. At least show me the work. So find a space on the whiteboard with a partner, or find a whiteboard, and then just go ahead and work, and then show me that you can do this. Okay. How would you actually solve for this? This was actually, if you want to write down notes, this is number 7 on month 6. If you got this wrong on month 6, this will be extremely helpful for your test corrections, because we're pretty much doing your test corrections right now. Well, what do you do? Well, so right now, what's the problem with this if we can't just plug in infinity? Yeah. Yeah, it'd be like an indeterminate form. So did you hear that, Nathan? Oh, you're doing it right now. You're taking the derivative of the top and the bottom.
That's how it works, right? I can take it out in front.
What you do is you take out, you have e to the power of 3x, and then you take the derivative of the 3x out. So it'd be 3 times 3x. There you are. Yeah. And then you see if you can plug in infinity and not get an indeterminate form.
You can't determine.
So you can apply this rule again and again and again until you get it. Intuition is what you use. I like that. Huh?
Just take you out again.
Yep. Okay. We'll go over this in just a second. Oh, you haven't taken the exam yet, so. Okay.
Because 6 divided by infinity is 6 divided by 2.
Okay. So this is our warm up procedure. So what I just announced was test corrections are not due at the end of this month. They are due at the end of month 9. Okay, all your test corrections. Okay. Right. So just giving you like 2 months to do it because 3 weeks is kind of brutal. It'd be like, aha, finish it now. So. But at the same time, you have homework. There's no test this month. Originally there was, but I'm not going to do that. There's no test. Focus on studying at this point for AP Calc. If your grade is not where it is, by the way, take advantage of the fact I give you extra credit for studying on your own time off of my books, off of like not my personal, but the textbook. Because like Deja's been taking advantage of this. Just go through like an AP Barron's book or something. Whatever work that you do on your own time, each page, like back and front, if it's littered with work and I can like legibly read what you're trying to do, I give you extra credit for it. Okay, so perfect opportunity for you guys to just study on your own. This is truly, truly independent study now at this point because, and of course, come to my classes because I'm going to be going over a lot of test corrections over problems that I think are just blisteringly hard. Okay. Very tough. Right. Yes, you can get a blister from how maddening and insane it was. Deja, I have your exam. It's not fully graded yet. It's just I have not. Huh? Yeah, only because we're gonna go through the FRQs today. So, and then kind of works out because I don't want anyone to know if they got their FRQs right or wrong. Okay, so what was your final answer for number 7? For this warm up here. You got A. So let's see how we did this, okay? So bear in mind when I talk, I'm talking to people that are watching the video as well. So I can't just go off like what you already know and like, I could just skip steps, okay? I got to go through rudimentary every little step, okay? If I can. Where am I going? So by the way, in case you did not hear me the first time, if you got this wrong in month 6, it's worth it to write this. This is your month 6 exam, number 7 on month 6. Okay, so I'm going to kind of highlight that so you guys can kind of read that. I printed out a paper here. And we presume that the answer is A. As x approaches infinity. Okay, so again, let's restate the problem here. Why could we just not substitute in infinity in here to find out the limit? So yeah, normally when we take the limit, we would have to take, we would just plug in, we would want to substitute in to see what the answer could be, what the limit could be, I'm sorry. So that's infinity cubed over e to the power, or e to the power of 3 times infinity, which is, in other words, will end up giving you an answer that is infinity over infinity. Yes.
So, as I understand, you can still kind of substitute, but you just kind of look at it as a smaller infinity over a larger infinity.
I see what you're saying. Like, this is an exponential problem, so right. This is exponentially
so
bigger than...
like dividing it by 0, or by infinity.
I guess conceptually, I don't want you to rely on that technique.
Right.
But I guess in an emergency, if you have, I'll come back to what Aaron just said, okay? Let's focus on just what the solution is right now. This does not work. technically this doesn't work. This is infinite. This is a very big quantity over a very big quantity, right? Infinity over infinity, and heck, you could make the mistake of that anything divided by itself is 1. So I don't want you to make that error. This is not undefined. Does anybody remember what this is technically called? This is indeterminate. So this doesn't work. So substitution does not work. So what could we possibly do to solve for this instead? Does anyone remember what the rule was? L'Hopital's rule. Or El Hospital's rule. Okay.
Is he like Spanish or
French, I believe. L'Hopital. I think. Don't quote me on that. Yeah, I don't know. I believe he's French. Okay. Best way to put it. So L'Hopital's rule says that for the top and the bottom portions here, let's treat them as different functions. And what we can do is we can just take the derivative of the top and the bottom part to see if we get to a state where you can plug in infinity and get a more legible answer than infinity over infinity. Okay, so we have the limit as x approaches infinity. And now let's take the derivative of x to the third power. What is the derivative of x to the third power?
3x squared.
It'd be 3x squared, remembering that there's the power rule, where you just bring down the exponent down as the coefficient, and the exponent that you currently have goes down by 1. So that's 3x squared. And then here, it's a little bit trickier, but e to any exponent, the derivative of that would just be the same thing. But don't forget about the chain rule. It's e to the third 3x, and then we're going to bring down, what is the derivative of 3x? 3. And then you ask yourself, can I plug in infinity in here without it going or becoming indeterminate? I'm going to write this in red, just like a little, diverting my attention to just test here. I just want to test to see 3 times infinity squared over 3.
There's still like e times, or e to the infinity powers.
Yeah, I mean, there's still infinity and infinity. What do you notice is giving me the problem? In fact, if I keep taking the derivative of the bottom portion, will I ever successfully get rid of e to the 3x? Not really. But if I keep taking the derivative of the top, what eventually can go away? The x. And that's what's giving me the problem, because every time I substitute in infinity, or every time I have an x, I have to substitute in infinity. So that's kind of a good way to say there is a light at the end of the tunnel. I can keep taking the derivative, because L'Hopital's rule, you can apply over and over again. But the bottom's not going to go away. It's the top portion that's eventually going to go away. So this is indeterminate. This didn't work. So if you're confused by what I just said, just hang tight. Just see that infinity cannot be substituted in there. So I take the derivatives again. I do another round of derivatives for the functions. 3x squared. What is the derivative of 3x squared? I believe
That
that.
actually makes it a little bit easier if you just kind of cancel the 3's first.
What's up?
If you cancel the 3's in the last one.
The threes in the last one?
Yes, there's 3x squared and 3 to the 3x. It'll just make the next derivative a tiny bit easier.
I believe. Yeah, I see what you're saying. Yeah, okay. I think I see what you're saying. I don't know. All right, so here, in case you didn't see that, here, there's 3 times x squared, and then x squared. The derivative of x squared would just be 2x to the first power, technically, which is just, if you want to simplify that even further, it's just 6x. Just so I don't skip any steps. Whoops. So you didn't even see it anyway, right? Hold on. Okay. So it'd be 3 times the derivative of x squared, which is 2x, which you would also just know as 6x. So I just want to deliberately show you that step. That's 6x. On the bottom here, it's 3 times the derivative of e to the 3x. So if you think about that, the derivative of e to the 3x is again 3 times e to the 3x again. Okay. So those 3's there are being multiplied. So now you have 9. And then again, you try substituting in infinity. And if you substitute in infinity, you're going to get 6 times infinity over 9 times e3 to the power of 3 times infinity. That's still indeterminate. So that still does not work. So we have to take it one more time. The derivative of 6x is just 6. And the derivative of the bottom is 9 times. So you have to look at 9 as a constant and then take the derivative of e to the 3x, which is just 3 times e to the 3x. So 9 times 3 is then 27. Now, can you substitute infinity without your answer being, or your limit being indeterminate? Yeah. If you do that, if you plug in infinity, there's no variable up here anymore. There's no x portion up here, so that's going to stay at 6. Oh, thankfully. Okay. At the bottom, it remains at 3x, e times e to the power of 3 times infinity, which is essentially going to be a huge number, infinity. But we have an actual whole number divided by a never-ending big number here, which should give us conceptually a very, very small value. Okay, that's close to 0. So
Because we're taking the limit, it is.
yeah, because we're approaching pretty much infinity or 0. We're approaching this 0 value. Okay. All right. Very good. That is again month 6 exam number 7. If you got that wrong. Okay. Now we're going to move on to the problem right below. So for your notes, these are pretty much your notes. We're just going to go over a bunch of problems. We're going to work on them together, and whatever we work on and we finish in class, I would write those down as notes to yourself. Okay. Here's the next one. So basically, we get to do the test together. That's all it is. It's like working as a class to solve this test, to work on this test. Yes, Deja. Did you?
Do you like 1, 2, 3? Did you do all the other ones before that?
Which one? No. I'm just skipping to like problems I think are problematic. Or this first one though wasn't like the first one was just literally a warm up to get your brain going. Okay, but the next ones though I think are the ones that most people missed. So good to discuss. Okay, so number 8. Let's go ahead and work on number 8 as a group. You may work on the whiteboards or you may work on the desk for this one. Okay, but whiteboards is by nature very, very nice and fun to kind of just mess around with. Okay, so please work on number 8. Please work together, by the way. Okay, don't work in isolation. Yes.
I'm on vacation, like getting up and walking around like outside because I have a concussion. So
Yeah. What? You have a concussion. You don't need to come to class if you have a concussion, good sir. You should might.
yeah, well, it's like the back end of it. I have a few more days until I'm done.
You need medical attention. I'm serious.
I already got it.
So you're okay? You visited a doctor?
Yeah.
Okay.
Yeah. Today's my first day physical activity at concussion day. So
Okay. So
just,
again,
I can't
medical
look at this
advice.
paper.
This was medically suggested to you by a doctor, professional doctor. Okay. Are you okay?
Yeah.
What happened?
Just calculus, right?
No, but what?
Plug in the 5/2 and
So you know how I do pairs, right? So I was in a lift, and my job, like, it would pause over to bring partner down instead of myself. So I brought my partner down to here.
Or you can just
And
figure
Mr.
it
She
out.
fell on me, and I fell backwards. I snapped. I smacked my head. Yeah.
I don't think I've ever been
Right, so you
concussed.
got-
So how did that feel, Ethan?
Did not feel good at all.
Like, were you just like super dizzy?
Yeah, I was
dazed?
dizzy and I had to get off. Like I was done. Like coach called it done. I haven't done anything for weeks. So my spring break was just sleep mostly.
Was she liked or no?
Huh?
Not like-
Sorry. I mean it was alright, but I had to cancel all my plans. So that sucked. And I can't go to Big Bear this weekend.
Oh, because is it your parents' call or your doctor's call to say you can't do that?
Parents go. I would have gone, but like when I do things like I go all the way. So if I went and like I got busy again, it's not worth it. So I have to stay.
Right.
I'll survive.
All right, Ethan. Just be careful, man. Yeah, I'm worried about you.
Oh, it's hard.
And actually, that seems
Nice.
Yeah.
because that's part of the going to be to 0.
You freeze this really quick. I'm gonna freeze this.
Getting my units Yeah, but then you plug it in and then it kind of counts into 2, so it ends up being sine of pi.
What are you doing? Good sir.
Have you opened the template yet?
Wait, why don't you just do stuff with power?
I'll just.
Yeah, you do the bunch of how does it cosine 2x, you can cancel that out for new substitution.
Yeah.
Thank you.
Yeah. It's,
Oh, no, you're right. It's greater than
I think I know it's more.
Alright,
So then you have to just take that.
Oh,
Basically.
this was from the test?
Over to.
This is from month 6, number 8. So
Oh, I was looking at this and trying to figure out what.
no, yeah. So like, here's the deal, Deja. I'm not going through one by one. I'm carefully selecting from month 5, 6, and 7 for the next few study group sessions. Now, I'm going to start picking problems that I think were the hardest to solve on your own. Some that I think were a bit unfair. Okay. Also, too, I might start trying to pick FRQs from last year's exam that are released now, I think, those problems. There's an infamous banana problem I'm trying to get my hands on right now. So, what's up?
I forgot my packet that I was going to give you today.
That's okay. Yeah.
And then I was also supposed to give you. I can't think of it right now, but I know I forgot 2 things. I'm like having a brain fart.
Not a concussion, though, right? 'Cause,
No.
Nathaniel, unfortunately, had a concussion, so that kind of scared me.
On the eyes?
We didn't.
Yes. I thought you said on the eyes. I'm like, I don't think you can just get a concussion on the eyes.
No.
I got you. Yeah.
Yeah, because that's scarier to me.
Oh, yeah.
Just like regular surface for some
Yeah,
reason.
yeah.
It's just ice is already so treacherous,
Yeah.
like weird and foreign. Yeah.
Because
Okay, I'll give it to you. Do you come Friday? I'll give it to you tomorrow or Friday. I just don't know what day I'll come. But I'll give it to you next week.
Sure.
Oh, okay.
Yeah, I'll be here Friday. Yeah, right, yeah. Of course, too, if I'm not here, like because I'm out of the office or something, because I'm like in the lab or I'm running around, you just cannot spot me, Deja, and it's frustrating. Feel free to just go to the mailbox and just drop it there too, because that's one place that does move. You know what I mean? So, yeah. All right, guys. How'd you guys feel about this? Did you guys feel any better than you did when you were on the exam? No, just a no, huh? Okay. All right. Don't worry. I'm okay. I'm not here to make you further deterred, but. All right. Let me. Sorry, I should have been doing this in the meantime. Let me fill in some ink here. 1/2. What can you not see? A, B, C, D, or E? This is my hand copy here. I guess it's all kind of washed out. You know, can someone do me a favor actually, and maybe turn down one of the lights for me? Maybe that'll help. It's just a really gloomy day, so I had to kind of keep the lights on a little bit. Is that a little bit better? Worse? Is that worse?
Oh, no, it's not worse.
I think it's okay, Nathan. I'm not sure. I just don't want your eyes to be really straining. Huh? No, that's what I'm saying. If we turn both off, would you guys want both
Remember
off?
when you wanted to do that for the test?
Oh, yeah. I don't know why.
That's good, right?
I don't know. It's just an insane thought in my head, I guess, that I thought it would have been better.
That was a really
I don't want to hear it.
No, but do you immediately feel like a decrease in energy or no? Was that just me? No? You're like, I live in the dark. Okay. All right, so it's hard to see, but they gave you one parameter, so it's kind of nice. I mean, this is a multiple choice question, so they gave you a parameter. U is equal to sine of 2x. Does anybody know where I go from here? What I should do? Yes, I like that. So find the derivative.
No, I forgot to
Okay,
No.
so first, if we want to find the derivative of u with respect to x, so remember, please, it's over dx because it signifies that it's with respect to the variable x. Okay, it's cosine. Oh, wait. Hold a minute. It's cosine of 2x, but what are you forgetting to do? The chain rule. You didn't forget to do that. I'm sorry. I just didn't let you get to it. Okay. So we got to take the derivative of the inside function, which technically is 2 cosine 2x. Do I put with respect to x? I don't remember. Okay. You know what? I think it's going to be better if I do... No, it's better if I do du. Sorry. If it's du and this is with respect to x. Sorry. So I think I did that a little bit incorrect. Okay. Sorry. So it was incorrect notation I had before. So the derivative of u is equal to 2 cosine 2x with respect to x. Now, remember, the original statement was of pi over 2. Oops, sorry. Did I write that incorrect? That's 5 here. Okay, so I had to fill in some of the ink here. Okay, so what we essentially want to do is we want to replace as much as we can in here. Pretty much anything with attached to an x term or like an x expression with all u's, including this du or including this dx statement here. We want everything replaced with terms of u. Okay, but if you notice, what is the difference between? Okay, so hold on. So before I ask that question, because I always phrase my questions kind of odd, I can see here that I could definitely replace sine of 2x with u here. So that's not a problem. The cosine of 2x, fortunately, can also be replaced with this whole statement over here as well. Or I'm sorry, du as well. So cosine of 2x can be replaced with du because du is equal to 2 times cosine of 2x. However, what does du have that the upper statement up here, this whole integral statement, does not contain? The 2. So if there was no 2 in the first place, we have to make this statement look like how it looks up here. So we have to get rid of that 2. We have to divide both sides by 2. Because cosine of 2x dx. What this tells us is that we're gonna substitute in cosine of 2x with respect to dx. So this, I'm sorry, even that dx has to be replaced. All of this is going to be replaced with du over 2, or in other words, another way of looking at it is 1/2 du. If I had to rewrite that the way that looks, it's 1/2 du technically. I just didn't want to jump steps, but I wanted you to see that 1/2 du comes from du over 2. So basically, all of this up here is going to be replaced with 1/2 du. So I think that's pretty good. We got, so 1/2, or we got u to the 5th power times 1/2 du is what I got so far when I replace everything up here with all my u statements here. Okay, sorry. And then we can pull out this 1/2 to the front, right? Making that 1/2 times the integral of u to the 5th du. Not a problem. So far, that looks like we can, what answers do we know that we, or what answers, or what could the answer not be at this point if we have this so far? Yeah, because the first one has a coefficient of -2. Okay, so that's not the answer. The last one's probably not the answer, but we're still stuck with this problem. So this is where I think a lot of you guys got tripped up, and I did not go over this in class. I actually feel really bad for doing this. Okay, so maybe we have, but maybe
we substituted the intervals with the u.
So this is a part that I think either I mentioned very briefly or I didn't go in depth as much as I wanted. Okay. Notice I intentionally left these spots here vague. I did not get to this issue until now. Okay. So if you guys are aware, if you guys think about it, originally before, this was the interval, right? From pi to the 6th to pi over 2. If you think about it, those are x coordinates. X, right? When we're talking about this integral, I want everything to be in terms of u if you want to do u substitution. That means I don't want these in terms of x. What? What does that mean? Okay, well, for one, we know that the relation between u and x was stated right here. U is equal to sine of 2x. So what we're going to do is we're going to take these two x coordinates, or these parts of the interval, pi 6 and pi over 2, we're going to substitute it in here. So we're going to put u is going to be equal to sine of pi over 2. And then we're also going to do another one, which is u is equal to sine of pi over 6. What is sine of pi over 2? Does anybody remember their unit circle?
Square root 3 over 2. Wait, hold on. No, that's for pi over. Wait, what?
Just for the record, that's what I was saying.
Multiply the pi over 2 by 2 first, because it's
Oh,
Yeah, it's just
Yeah.
pi, it's 0.
That one is
Look.
just
wait.
pi. It's sine
Zero.
of sine
Thank you, guys.
of pi
Thank you.
and then
Thank you.
sine of pi over 3.
sorry. Sorry, it's 2. Sorry, I made a mistake. I'm so sorry. Okay, the x coordinate is pi over 2, but I totally forgot. I even just said it. Sine of 2 times x, which is the x coordinate is pi over 2, okay? Which canceled out the 2s, so now we're taking the sine of pi, which is just 0, right? And then the sine of 2 times pi over 6, which simplifies to, let's see, yeah, pi over 3. So what is the sine of pi over 3? Square root of 3 over 2. What I intend to do is these are now going to replace the original x coordinates. Because remember, I want even my intervals to be in terms of u. My original x coordinates are that determine the interval is pi over 2. That's going to be replaced with 0. 0. So that is a blank circle. I'm putting in 0. And then in here, in this spot down here, should be my other new u coordinate. Not x coordinate, u coordinate. My x coordinate originally was pi over 6, but when I talk about everything in terms of u, I have to plug it back into u, that u coordinate, or that x coordinate of pi over 6. And then I got u to be pi over, or was it negative, or root 3 over 2. I'm losing my mind. I'm sorry about that. Root 3 over 2. And that's going to be your final answer. So, out of all your choices, what gives you this integral from root 3 over 2 to 0? It was D. Okay? Any questions on that one? Yes. Yeah, of course. Yes. Let me see if I can zoom out for you if you'd like that. Also, be aware that these videos are going to go online as well too. So, yeah, whatever we don't have time to write down, then yes.
So every time you're doing the substitution with integration, are you supposed to change the limits like that?
Yes, you are.
Time.
Every time. So I think the reason why I didn't really emphasize this too much is we kept dealing with indefinite integrals, which mean that there's no intervals. So I never really had to come across that issue where I brought up to you that, yeah, you do have to change the
Because the
interval.
book made it seem like, I remember reading in the book and it made it seem like you were only supposed to do that for convenience. It said something like it makes it easier so you don't have to do crap later.
Oh,
It's,
I'm sure it said that.
I think I might be able to explain it.
go ahead.
The other way to kind of do this is to just integrate, then plug in the
Oh, yeah,
sine
that's what it
2x
was
back
saying.
into the u,
I
and
didn't
then
know
put
that.
in the parameters again. But since here the answers are in terms of u, you have to put in the parameters in terms of
Does that make sense? Yeah, that was
It makes sense, but I don't know how to do it. What he said.
Oh no! What he's saying is like usually you don't have to do this at all because once you figure out u's, you plug back in the original x statements. Once you integrate u, right? Like you'd figure out that it'd be like in green. It means that this is just hypothetical. Don't actually write this. This is not important to the big picture here, or to this smaller narrow picture here. Okay. This would be like 1/2 times 1/6 u to the 6th. That's the integral of u to the 5th power, right?
Yeah.
At this point, I would just plug back in u, which was 1/2 times 1 to the 6th sine of 2x, right?
Yeah.
And then don't forget the interval originally was pi over 6 to pi over 2, right?
Is it
Well, the thing is, are we back in terms of x or u, Deja? No, hold on. So let's look at where we are now. Do you see any u's in there? Are we dealing with u's anymore? So we go back to our original x coordinates, our interval.
No, but she's saying that the sine of 2x should be to the 6 pi.
Oh, yeah.
Yeah, that's what I was.
Sorry. You're probably like, what other rule is he introducing right now? No, I don't mean to do that. It's just a slip of the fingers in mine, okay? But at this point, yeah, I wouldn't need to worry about. You see how everything's back in terms of x?
Oh, and that's when they just use the same.
Yeah, so we never really had to encounter that problem of having to put everything in terms of u, including the interval.
So it's just two separate techniques of doing the same thing.
Exactly.
But in this problem, it doesn't ask us for the solutions.
It does not, yeah. So it's asking you for the integral, technically all in terms of u. So that means everything, including down to the intervals, or the x coordinates for the parameters for the interval. Okay, the limits for the interval. Okay. All right. So let's go ahead and move on and give you another problem. Okay, so let's move on to a problem from this month's exam. So a multiple choice problem. How much time do we have? So around 8:50, I think we're going to switch over to FRQs. Okay, so let's go over number 89 on the exam. Okay, so flip over to number 89 on month 7 exam. That's what we're going to work on now. Now you have a little bit of a resource because you can look at what you did to solve for number 89. And then if you look above you is another really tough problem that we're going to eventually hit if we have time. Actually, you choose for me. What do you want to? Yeah, Ellie, come on over. So again, Ellie, these are not fully graded. I need these back because FRQs we're going to leave till the very end. It's going to go over. Okay. All right. Which would you guys like to go over, actually? 88 or 89? Yeah, on this test. All right.
Oh, 5, I got right. Yeah, I can do it with 5.
I love your confidence and like your sense of humility. It's just like I don't care. Yeah, whatever. Okay. Well. Okay. So.
Can I just like assume that I got an A and do it on the test, do the corrections on the test?
No. Be careful. Your FRQs might be completely wrong. Who knows? Yes.
Should I like leave since I didn't take the test?
I don't know. It feels weird to kick you out of class at the same time. But then again, you are exposed to the exam. All right. I'm going to give you the option to leave. Yes. But I don't think I can forcefully tell a student to. No, I guess I can. Because this is a weird. Yeah. Okay. This is an exam, so I cannot. Yeah. So don't. You may leave, Christina. I'm sorry. Yeah. Sorry. I'm nicely dismissing you right now. Sorry.
Are we gonna like?
Are you doing this for the rest of class?
Pretty much all of month 7 exam.
But after I take the exam, I
no, I'm getting real.
Yeah.
see how.
Sorry about that. Just to be fair, I guess, to the other students. Or else you might get like a gargantuan A, and then all the other students are like, "But I didn't get to see the answers before." You know, like faith. You know, rightfully, I'd be pretty mad too. I'd be like, "What the heck?" You know, sorry. And it's no fault of your own. It's just Mr. Wee's not making an executive decision, so I have to make a decision. So, I'm
Are
sorry.
we gonna go over more questions from month 7?
Yes, it's just fresh right now. That's why I'm going over month 7. But next week, I'm going to start going back on month 6 exam. And then maybe even the third week, I'll go back to month 5 exam. I'm just going to go back and forth. And then, but sometimes if I feel like a new FRQ that I found is like a lot more important, I think, or I feel like might be something that might be in the AP exam, I might choose to do something like that too, like integrate that. So yeah, Allie.
So we have 2 test corrections?
No, not do this month. Do month 9. At the end of month 9.
All of them are due month 9?
All of them. Month 5, month 6, and month 7 exams. Okay. Yeah. Okay. All right. So let's go. Yeah. Okay. Go ahead.
Do we have any tests this month?
No. So originally I had one archived. Like I guess she administered one. So I don't know if it's better to keep you in practice to do that. But I think it's a little bit more important to go back and just
Obviously.
yeah,
because
quality
we're all
control.
wrong.
Okay. All right.
The month 8 test, the one written by Miss Carmichael.
I believe so. Yeah. Did you want access to that at least? Yeah. No?
Sure.
Yeah. Kyle, yours. I don't even want that. No. Don't deter my focus. Okay. Okay. So what do we want, guys? Do we want 88 or 89? Which one do you remember?
All 12.
What did I do?
Want to do 88?
Yeah, I'll do 88.
All right, guys, let's go ahead and work on 88 together. Let's at least discuss what we might be thinking about. I'm sorry, Christina. So.
I got 88 right. Maybe.
Yeah. Pretty classic problem.
Okay, guys, I'm gonna give you guys about 5 or 10 minutes to work on 88. Number 88 together. Number 88. No. Okay, let's get back on focus, guys. Number 88. Let's work on 88.
I got it.
We just guess. Just guess. Hey, you're better guessing right.
I thought I was a big guess.
No, but that's the.
You do way better than me on test.
We want the rate of the shadow.
I don't
So we
understand.
I don't like overhearing guessing, guys. Let's work on. Let's.
Techniques.
Yes. Let's work on trying to actually solve it without guessing, without having to guess.
I know that I guessed because I didn't
Yeah, I think we're both that one.
This is really weird.
Wow.
Oh yeah, what's the information?
A person whose height is 6 feet is walking away from the base of a street.
Along the straight path.
I don't see the place.
Along the straight path at a rate of 4 feet per second.
What a big street.
Okay.
If the height of the street light is 15 feet, what is the what is the rate at which the person's shadow is lit?
It's like the hardest part isn't the calculus.
I don't know
It's
where to
finding
start
the
either.
function.
Okay, so logically.
Yeah, this is extremely tough.
Calculus itself is pretty
Your
easy.
shadow is shorter.
Like taking derivatives.
Yeah, derivatives.
Yeah. Like that. I guess the process isn't too bad, but yeah.
The lights here, we're walking.
That has nothing to do with the rate
I
at
don't
which
know, I'm just saying, like, logic, like, I think 10 foot per second. That's one, but shadow's getting smaller.
well, you guys are testing it.
Look at the wall.
You can't
Oh my
test
god,
it.
it's getting, it actually says that it's getting longer. The problem actually says it's getting longer.
It's getting shorter.
It doesn't matter. You have to do what the problem
Why don't we
says.
all take our flashlights out our phones?
Logically, it's short. Alright, so how do we start?
That's a funny scenario for administration to come in and see.
Oh no.
Like full flashing our phones. It's like we're all losing our minds.
You could have a scaled down version.
Ben,
What's that?
can you teach us?
You could have the scaled down version, maybe like 15 inches. You could hold the flashlight up. You could have a 6 inch.
Yeah, I'm just imagining we're all huddled around the table in the shadows.
Yeah.
Mrs. Apollo's like, what are you guys doing? We're looking at shadows, Mrs. Apollo. We're looking at shadows.
It says hello.
I think that's like racist.
It is hello.
You guys want to keep working on this, or you guys want me to go?
No.
Well, just did anybody understand it?
Well, I mean,
I
they
get
get
it.
it. Physically, the fact that that's what we normal drawings, but you can't.
Sometimes AA are uncomfortable.
Okay. All right, so let's go ahead and work on this here. So let's take a look at our situation that we have. We have a lamp that is, how tall is this guy? It's 15 feet.
No, the guy is 6 feet.
Okay. Then he casts a shadow. Okay.
It's smaller, can I just say?
Call it like. That's what that's.
Or how about just S for shadow? Not just shadow. Make it a little bit easier. Okay?
But you just saw it with my shadow.
Okay, so hold on. So let's see. The information we have right now is he's 6 feet long. The street light. Let's see. There's a street path along. Let's see. The street. Let's see. From the base of the street light, along a straight path, there's a rate, okay? So he's moving, that person's moving away at a rate of 4 feet per second. So what this is going to end up being is a related rate problem. So that means there's going to be variables and there's going to be derivative of variables as well. When you see a rate, okay, like per second, that's where you got to think to yourself, per second, if I remember, is sort of like a change, okay, per second. That is a derivative. So if you think about it this way, there is a distance from him to the light pole that we don't know. We can use a variable to indicate a value that we don't understand, x, and we know the rate at which this changes, that distance between him and the pole changes, dx. There is a rate of change of x. If you think about that, that's the distance from him to the pole. It changes at a rate of 4 feet per second. Okay. Also, there's a shadow. There's a length of the shadow that we don't know, but it's asking us right now, what is the rate at which the person's shadow is changing? So what that means is I'm actually looking for the rate at which that shadow is lengthening, dt. Lengthening just means a positive value. Okay, it means or it just means that s is going to grow in a positive direction, or like s is going to be a positive number. That's all that means. Okay, so this is what we have to solve. Okay, but it's still not easy. I'm not going to say that. Yeah, now you guys got it. No, this is an extremely tough problem. Okay, this is a huge stretch. So this is a good problem to go over because it's a common type of problem that you see in AP calculus exams. In fact, every year I think they have some kind of variation of this exam, or at least for about 2 or 3 years of past exams I've looked at, they had some kind of variation of this problem. Okay. Do you see the shape that maybe this whole situation scenario can make? It's a giant triangle if you look at it. From the top of the lamp pole.
Yeah, that was amazing.
Oh, thank you. Oh no, it's because of resolution. If you see it like in actual perfect resolution, it's not a perfect line. Okay, so you have a giant triangle. So I'm going to try to draw this triangle again. Well, actually, I don't just see one triangle. I see another triangle.
The little mini one with the dude.
He's not dead. He's just represented now as a bigger stick, if you think about it. And if you don't remember,
That's what I drew.
as long as it doesn't really say, but as long as he's perpendicular to the line, or he's at least at the same angle that he makes with the ground, as how the street lamp makes an angle with the ground as well. These are similar triangles. So if I had to draw these separately, it would look like this. Here's 15, and then the length of this guy is x and s, so it'd be x plus s. And the smaller triangle is 6 feet.
Or 6 over s. Or s over 6.
S is shadow.
Yes.
What's X though?
X is just the distance between the stick figure man and the light.
Yeah. Awesome.
So we still got to make an equation with variables and so forth. That's the hard part, but can we make a statement between these two triangles at least?
Yes,
They're similar because they're actually within the same triangle. They make similar, but what does similarity mean though? What does it mean? They have a weight?
oh, they're proportional.
Proportional in a way, yeah.
A scale or something? Are you saying?
Pointed
Yeah.
out there.
Oh, is that what you said? Weight? Because
Acid rate.
oh, they said weight because that relates to the word scale in a weird way. Okay,
Yeah.
that's pretty clear. That's pretty clever. Okay, so you can say that the way 15 and 6 make a ratio, or 6 over 15. I like for some reason it's just you don't have to do it this way. I just like going lower numbers to higher numbers.
Because it looks like an improper fraction.
Yeah, I just want to look at it. So I have 6 over 15. These two sides make the same ratio proportional to the ratio that these two sides will make. S over x plus s. Still not easy, okay, so bear with me. You cross multiply at this point. And then now we're left with something that we can kind of work with.
Like I understand it, but I'm always amazed by like
What you were supposed to do, yeah.
No, yeah, I'm thinking like, how would a kid get this on a test? Like, I wonder what's going through his mind. Oh, I mean this, and I haven't.
And that's why the bar is relatively lower to pass this, is because it's a very hard concept to understand. Yes.
Really quickly, could I see the answers again?
Okay.
I think I got an answer. And I
You will. Okay. What did?
I got 1.6. Is that anything on?
It is not.
No, that's wrong.
That's what I got. I got it wrong.
Okay. Hold on. We're getting close. Okay. So let's distribute the 6. And we have this statement here. And then why don't we subtract? Now this step you wouldn't know why to do that. So, but I would just recommend putting the variables by themselves if you can, but you don't understand why. Okay, so maybe I shouldn't teach it to you like this. All right, so we'll just leave it like this. I don't know what's going to be more confusing for you, but
well, if the variables are on their own, then you take the derivatives.
That's kind of where I wanted to go, because the whole point in setting up this equation with x's and s's is because if you remember, the whole point is to get to a part where we can put in derivatives into this equation. All right, we can start talking about rates, right? Dx and dt. And essentially right now I got 6x plus 6s is equal to 15s. Now what I can start doing is I have a statement. I actually have a mathematical statement to work with where I can take the derivative of that and plug in these values. Because the derivative of x has a value. And the derivative of s has a value that I'm trying to solve for that I don't know. So in order to... Hi there. Okay. Okay, so what we can do now, this might be a little bit confusing if I just move the s's over right now, but what you're supposed to do is you're supposed to take the derivative with respect to time. Sorry if you don't like that, okay? It's just let me backtrack really quick. These derivatives that we're taking of, okay? The derivative of how x changes and the derivative of how s changes, okay? They're with respect to time. Because remember, you can think of it this way. It's like 4 feet per second. You can sort of look at like dx is a change in x, which is feet. That's all in feet, with a change in time per second, 4 feet per second, okay? So I want to take the derivative of both sides with respect to time. The notation in which that will look like is taking the derivative of this side with respect to time, and I have to take the derivative of this side with respect to time, okay?
Also, because there's an t in there, would you have to use the implicit? It'll be implied that x has is some kind of equation with t in there. Yeah, that's correct. Okay, but you don't have to worry about it too much, because what is the derivative of 6x? Just 6. So hold on, guys. So refrain from talking really quick. Just let me get to this point here. So you have 6, but you technically took the derivative of x, so that's dx over dt. Plus, so the derivative of 6s would technically be just the constant 6, but it's implicit. It's implicit differentiation in that we didn't really know what the derivative of s was. We don't know it, like within this here, if it was some kind of function that had t in it. So we write out the derivative of s with respect to time. And then over here, it ends up being the same thing. It's the constant 15. And you took the derivative of s with respect to time. And then what you end up seeing too, I know you probably have never done anything like this before. It looks kind of scary, but these are technically like terms. So if you wanted, or you should, you can actually subtract the like terms from both sides. So you end up getting 6 times dx, or 6 dt, dx with respect to t, is equal to 9 ds with respect to t. And I know it looks really freaky what you have here, but what this becomes is a substitution problem. Because dx over dt, you have an actual value for. It's 4 feet per second. So once you plug that in, it's 6 times 4 is equal to 9 times ds dt. You have 24 is equal to 9 ds dt. And then remember, we're just solving for a singular value for ds dt. So if you treat this as sort of like an algebra problem, we divide both sides by 9 to get ds dt by itself. And this, if you punch in your calculator, actually, can someone punch down their calculator? It's just 2.667. It's 2.666 repeating. But if you round up, maybe if it's 666 repeating on your exam, it's not going to have repeating, but it'll be B. Okay? So go back home and study on that. That one's a little bit tough. Okay? So you can write.
It is. That's what I was saying. I don't get how it goes.
It was really tough. Well,
The hardest part, as I understand, is just to find the function of a similar triangle. After that, it's just calculus.
That's true.
I think explaining it for it to make any sense takes a lot more time. You have to, I mean, you're not having to explain it on the exam. You just have to really just do it really quick. And logistically, these things are a lot quicker, you think. Like graphing, right? You actually, graphing actually takes a long time. That's a bad metaphor.
I found out I actually set it up right. It's just I did the calculator online.
Oh, okay. That's very nice. And then I believe for an easier solution too, I think the last person's exam I did glance over their FRQs was Ben's. Ben, you had an alternative method that was actually a little bit quicker too, in the way that you set up your similar triangles. So if you're interested, maybe see Ben's solution. It's a lot cleaner than this actually too. It was only like 2 steps, but in order to understand it,
An FRQ in 2 steps?
No, wait, it wasn't an FRQ.
no, it's just a multiple choice. But he did it like in just a few steps. Yeah, but your proportion in your similar triangles was pretty good. I didn't see it that way. Okay. All right, guys. Here's the FRQ. So if you guys can, why don't you guys work with each other for, we're running out of time, but why don't you guys work with each other for about 5 or 10 minutes, and then on the number 2 FRQ, you can work on A, B, and C, okay? Whichever ones that you were able to solve for. This was a tough one. Huh?
Because you didn't grade them yet.
So what
Don't change the answer. Just, yeah, that I like that. Thank you very much for asking with honesty. No, please don't change the answer, okay? But you can use your answer right now to try to come up with something, okay? But no, you can't change your answer.
I could have been wrong. I could have guessed.
Really?
I don't think I attached my.
Omar, yes.
What did you get? I don't have it.
Y'all got
Oh, yeah, it's in my stomach. I got it. Wait.
Did you guys do it?
We're okay. We're okay.
You didn't do it at all?
Yeah.
No, I didn't.
Yeah, what did you get for number 2?
I get
So we're similar.
We're all
Yeah.
similar except for Omar.
Oh, what'd you get?
Really? 2.76.
I got 2.7.
I got 2.7.
I went 2.4.
We're around the 2 area.
Omar, what'd you get?
But what if
3.9.
Omar's is wrong? Right.
Omar, what did you get?
3.9.
We're all sat here in
Okay,
mid-range
Wait, let's
twos.
do it.
Let's work it out.
Alright, so we're gonna solve it in terms of y. This is a one-time function, not one function.
Agreed.
Okay, so you wanna do it again?
Okay.
Okay, ready?
The original problem is y is equal to natural log of x. Y is equal to y minus x, so we have to solve it over x.
I got x equals.
So which one? This one?
Yeah, for the first one, I got x equals e to the y. So I don't need to do that.
Yeah.
Okay, you need to make your y.
Want me to update this one? Happy?
Yes, I'm very happy now.
Next
Okay,
one,
and then
x is equal to
5 minus y.
X. 5 minus X.
y.
We're doing it with, we're doing the problem with respect to y. So we
I
have
think look,
to
we're looking
change
at this.
it to
Why?
because we're doing it,
It's easy
we're
this
not
way.
doing the problem with respect this way, we're doing the problem with respect this way, so we have to change.
Okay, we're
This-
Are you sure about that?
Yes.
We were debating that for like 20 minutes.
Nathan said that we were
Yeah.
gonna do it this way, so I was just going with it.
It's easy this way because look,
Oh, Nathan.
you have a bound top and a bound bottom.
Yeah, he's right though.
Yeah, I thought this one should always on top.
Aren't we right?
You can do either way. It's up to you
Alright,
guys.
anyway, we're just
Why
gonna
should
make
we
it
keep, why can't we keep it the way
Because the
that
other
it
way
says
is
on here?
confusing. Alright,
This
okay,
way is
listen, we have this way, we're in agreement.
You don't know the upper parameter for
It's one.
Yeah, you do, bro. It's 0 to 1.
Okay,
I
well you
remember
can set
calculating
them,
that.
okay, well you can set them equal to each other and solve.
Yeah.
Yeah.
Okay, listen, moving on, yeah.
Okay, so
That's
ln,
correct.
so y equals ln
just
5
happy about
minus
this.
y.
Why don't
I
you
wasn't sure about it. But
share with your table mate how you achieve
Can I
that?
change my answer?
No, you
This is my
cannot.
whole integral, and I use the calculator function to find the intercept of the two graphs.
So we have to set
And I
them
just
equal to
added
each
them.
other. To
Oh,
find where
that's
the
good.
intercept.
That's what you.
Which
And
is
it was
what I was
fast,
giving you
and
the
I
answer.
saw it.
I like it. No, it's very good.
Wait, don't we have
Graphing
that
calculators are awesome.
Actually, I forgot. How did you find the point of intersection? Did you just trace where it was, or yeah? I think there's a function where you can do that. Right? You just put in,
Oh, wait,
Second.
There are a bunch of things you can find maximums, and then there's
and you just choose. Like you have to choose the 2 lines that you want.
yeah.
Okay.
Okay, go with Omar.
So it just
Whatever.
works.
1.3.
I'll show them how to do that. Thank you very much. I'll show.
Don't tell me
I
about
did
the
on the
answer.
test.
No, I did, and you told me.
You were right. Wait, what? He got the answer
You did.
in 2 steps?
Fire? I don't
You got 1 point?
Well, it was like in 1 or 2 intervals, I guess.
Wait, are you sure when you
Are we on the right track?
Because Omar used a different answer than that.
Yeah,
I don't know.
How do I solve this?
Oh,
Honestly, I have no clue what's going on.
I don't know.
just
No.
just as a reminder, you guys are free to use calculators on this problem too.
How do you know how to use it?
Now we're intersecting.
All right. Well, I think I do need to stop you guys right now.
Yeah.
Well, hold on. You still got 10 more minutes of class. I just want to go over it myself. I'm a little bit selfish with this. So it looks like you guys were on the right track in terms of thinking about what you guys had to do. And then why did you set those two up equal to each other?
Because we're trying to find the upper bound.
Trying to find the upper bound by finding the point of intersection, right?
Yeah.
So, okay. So let me grab my calculator really quick. So you have 2 ways to attack this. You can keep everything in terms of x, or you can change everything in terms of deal with everything in terms of y, the integral. I mean, so here's what we can do. There is a problem here because we have 2 different functions, right? So we can't just take we can't just take an integral from 0 to, or like 1 to 5, which is the other point here, 1 to 5 of one continuous function, because obviously we have two different functions for which the area is going to fall under, right? We have this here and this here. Think about it. We have this line here and this line here, right? So if you think about it, where they meet is sort of like a boundary, and you could take the area of these two coordinates, or these two spots here and here, the area underneath this curve, right before it switches hands to this curve here, in which we could take the area under there. So there's no function that can kind of take into account both curves, okay? So we have two options. We could take two integrals. We can make two integrals between from 1 to wherever they sort of intersect here. And then we can go from here and we could take the integral from here to here, 5, under this line. Does that make sense? Or we could switch the whole thing. We could switch the way that we look at things in terms of y. You'd rather do it this way. Okay.
But then you'd still have to find the intersection.
You always have to find the intersect. So first, before you start doing what you did over there, that would lead you, I think, to the right answer as well. Simpler solution, more elegant solution is just to find the intersect here. And how you would do that is you would graph. Oh, I think this.
Yeah, you have them.
Wow, that's so funny. Yeah, I just literally picked this up too. So this is like the last thing someone worked on. Okay, so this is the ln of x as one of the functions. The other function is, so we have this line here, ln of x. The other one is 5 minus x. And then you just graph it. Okay. Yeah, it's just the scaling is really bad right now. So let's see if I can.
You have to go to the window.
Yeah, it's like right that region right there. Okay, but we want to find out where they intersect right around here. So I think you do second trace or second. So you can write this down. You can put second trace. You're going to go down to intersect or number 5. You can either press the number 5 key or just press enter on that. All right. In the first curve, you just choose between one of these two curves. Okay. So let's see. I'm going to choose this curve as the first curve. I don't think it really matters. I'm going to choose the. Oh, yeah, here it is. Second curve here. So you just so sorry. Do you want me to show you that step again? I didn't really explain it that well. So second calc, intersect, and then you're gonna choose the two lines you want to see the point of intersection. I say I don't really care which one's the first curve. I'm just gonna pick the bottom guy first. That's one line, and then you have to establish the other line that you want to find out where between which two lines do you want to find out their point of intersection. Because imagine like a ton of different lines. Which intersection do you want to see? Well, I want to see the intersection between these two lines. So I chose these two lines, and then a guess. I'm just going to press enter when I ask to press to guess. Just press enter. Those are your coordinates for where that point of intersection is. Blown up, it's going to be right here. So the coordinates are right below. It's 3.69 approximately, comma 1.3. That's about 1. So instead of having to solve for it, if they allow calculators for this, just find out the point of intersection with this function in your calculator, okay? So here you have two options. You could take the integral in terms of x, from 0 to the x coordinate, where this stops. This is 3.69, if you think about it, right? It makes sense, doesn't it? Because that's the point of intersection. We can kind of draw a boundary that's perpendicular, okay, to the x-axis with that point of intersection. You can put from 0 to 3.69. For that segment, that integral belongs to this curve, which is ln of x. That's with respect to x.
This is actually the second problem, right? No.
No, this is the first one.
It's 1 on the lower.
What? I'm sorry, what?
Put 0. This would be 1.
Oh! Sorry, I'm so sorry. Thank you. 1 to 3.69. And then, don't forget, this whole region consists of two different integrals. It's this integral and then this integral. So the other integral could be from 3.69 to 5. And then it's the area under this curve, which is simply 5 minus x with respect to x. You could solve for this by hand, or you can use your calculator. So for your calculator, you just go to, I believe, what is it, math? And then you go all the way down to f int. Okay? Yeah, I know, I have the odd one here. And then what you do, I believe, is what is it? The function first, which is ln x. So it'd be ln of x. And then you have to set or tell me what the variable is. It's in terms of x. And then your parameters are from 1 to 3.69, 1, comma, 3.69, and comma. That's approximately 2.13. It's a lot of rounding. And I'm going to do the same thing with this one here. Shortcut method is I press second enter to kind of repeat what I just repeated here. I could just replace a few things. Or if you don't want to do that, let's not do that. Let's go to math. Go to fn int. And then you take the integral from this for this guy, which is just 5 minus x, comma, x. And then your parameters are going to be 3.69 and 5. 3.69, comma, 5. That is approximately 0.86. If you add those two together, 2.13 plus 0.86, final answer, if you get around this answer, not 2.4 though, it has to be around 2. I would say the official answer in their key is 2.986, but it's okay if they see that you round it like this, 2.99. That is your final answer. That is fine. That's fine.
She's close. I think you should give it to her because I'm closer. I got 2.78.
But what were your parameters though for your integral?
I did the parameter at 1 because I thought that's what it was showing, and if I did that, I would have gotten it right. I did all my math correctly.
But if you, I see. So here,
I thought that's what they were showing because look, I have a good rationale because this they didn't give you the numbers, but for this they gave you the numbers. So I thought, oh, we're supposed to use that. They just gave it to us.
Okay, I'll give you credit, but I'm still gonna take off a point because you should have been able to kind of see visually that.
I know I should have checked either way.
That it should have, like they actually intersect at that y point of 1. So.
Yeah, but that's the only thing I did wrong.
Oh, and if you wanted to do it in terms of y, by the way, let me see. So if you want to flip it on a script and turn it to y, let's see. How you would do this is, so this line originally, right? This line originally was, what is it? Y is equal to 5 minus x. But if you want to look at it from the perspective of, let's say, I guess from this perspective, I guess I'll just say this perspective because I don't know the proper words for it right now. I would just add x to both sides. And then, not x. 5 to both sides, or what do I want to do? I want to subtract 5 from both sides, I guess. So you'd have y minus 5 is equal to negative x. Sorry, I'm kind of going oddly here, my order here. I'm not going down, I'm going up. And then I want to, what is it? I want to have this in terms of positive x. So I have to kind of give this a negative sign here. Whatever I have to multiply this by -1. I have to multiply whatever I do to one side of the equal sign. I have to do the other side. This would basically be 5 minus y is equal to x. So that's the top portion. The bottom portion was y is equal to ln of x. But remember, I want to write everything in terms of x. So if you think about it, if I take this whole expression as a power with base e, and I have to do whatever I do to one side, I have to do the other side. This becomes a power to base e. It'd be e to the y is equal to x now, because this kind of cancels out if you think about it. And then your integral now will actually be from the x-axis from here, from 0 to the y coordinate. Okay, the y-coordinate. We're looking at the y-coordinate, and we had the y-coordinate. It's technically 1.31. So your integral in one straight shot here could have been 0 to 1.31. And it's the top curve, which is 5 minus y, minus the bottom curve. Because we want to find the area that's encased between two curves. So it'd be 5 minus y minus e to the y with respect to y. In your calculator, you don't have to put it, you don't have to say y. It really doesn't recognize, I mean, at this point, a variable is just a variable to the calculator. You can just put math, or I'm sorry, what is it, second math? Yeah, no, just math. Go to FN integral. And then remember, your calculator really doesn't care if you're talking about it in terms of x or y. Just give me a variable. Okay, you've already gone this whole thing in terms of some kind of variable. Okay, so what I'm going to do is I'm just going to say f minus x. I can do that. Okay, it's okay if I leave it an x in the calculator. It won't be able to differentiate. It just looks at it as in some kind of a variable. Okay, I'm sorry, it's f of x minus e to the, what is it, second ln gives me e to the power of x. Okay, I'm going to say the variable was x. The parameter is from 0 to 1.31. Whoops. Close parentheses. And actually, that gives me a slightly more accurate value. If you plug this into the calculator, you should get 2.986.
Which would be even closer to the answer I got.
Yeah. So which is okay, guys. That's the end of class. So we didn't have time to get through the rest of the FRQ. So maybe I should make a video on this. Oh, actually, one more resource for you guys to. I didn't realize this, but I just learned this last night. This was pretty crazy. If you go to YouTube.com, the great thing is these exams that I grabbed from, these exams, or not I grabbed from, okay, but these exams, the way they were made, these are literally just practice exams. This was a practice exam from 2012. The handy thing about that is if you put in AP Calc, let's say practice exam or something, I think, or it's a 2012 free response. If you look here, I know it's kind of odd here, but it was technically the second problem on this exam, on the 2012 exam. This is number 2, free response 2.
How are we supposed to know this is 2012?
What? Oh, you didn't know that. I'll tell you that. It's 2012. Sorry. This is an exam based on the 2012 AP Calc exam. There are videos made from other people that actually went over a lot of these problems already. So it's kind of nifty. So it goes, and I realized all the multiple choices on here as well. Okay, so if you're wondering what the past exams are, ask me, and then I'll check to see which exam Ms. Carbajal pulled it from, and then you guys could probably check for if they have responses from 2007 exams, 2008, and so forth. Okay, so just a nice little handy resource if you want to do more test corrections on your own. Okay. All right, guys. That's the end of class. So.